All right. This is our 49th lesson on the study of the biblical flood. I'm Marion Fox. We'll be continuing our discussion of radiocarbon dating as carbon-14. It's a radioactive isotope of carbon. And we'll be looking at some more information about radiocarbon dating problems. It's often correlated and calibrated with dendrochronology. Now, that's a big fancy word. Dendros is the word for tree in Greek. Chronos is time, and ology is from logos, the sayings. So dendrochronology is the sayings regarding, or the study regarding the dating of things by the tree rings or datings of trees. And so it's usually tree rings that they're using to date them. Interestingly enough, fish like bass will have rings on their scales. You can tell their age by the number of rings on their scales. And that's kind of like tree ring dating. There are other problems with sources of radiocarbon. And we're looking at some other problems with radiocarbon dating. And as we looked at the last 2 weeks of radiocarbon, radiocarbon dating system is calibrated. It is by tree rings of several different species of trees, bristlecone pines, redwoods, and oaks particularly. And so these are the three main trees that are used to calibrate them. Now, to calibrate something, you adjust it by some kind of a standard. So the tree rings become the standard, and they will cross-reference the tree rings with the radiocarbon and go back and forth with them. But we're going to see some flaws in their dating techniques with this, some serious errors in it, some serious logical errors, and really bad statistical errors as well. These rings go back to around 2,000 years, with bristlecone pine trees go back about 4,000 years. Bristlecone pine trees are the longest lived tree that we know of. In order to go back further, the rings must be overlapped, so they'll overlap them. We get a problem or several problems with this when we do the overlapping. Here's tree rings. If you notice, here is just a stump of a tree. We can see the rings as they go out. You can count the rings and tell about how old the tree is, but there's several assumptions that are made in order to count the tree rings and know how many years old the tree is. So this is a problem here with it. So there are some assumptions that are made, and we'll be looking at those assumptions as we go through this. Now, here's what happens. They'll have a set of trees that are maybe even still living, and they'll date them back with tree rings and project it back in time. Then they'll have another set of trees that are fossilized. And so they may be in wood. And so they'll take this in fossilized wood and they'll overlap it. And they'll try to correlate the rings. As you see, I'm moving the mouse pointer up and down. These two rings supposedly correlate. And so they get the correlation of the rings, overlap them with this time frame, and then project with this second one back further and correlate it with another object or another piece of wood. And so they supposedly overlap them and correlate. So this sounds good on the surface, but we want to remember one thing. Correlation does not always prove cause and effect. There may be other reasons for things to correlate that we're not aware of. So we need to be very, very careful about using this because it has a potential flaw in it. And we'll see some other flaws and other problems with the correlating of the various overlapping of the tree rings to correlate them. Correlation does not prove cause and effect. That's a pretty important principle of statistics. correlation is necessary for there to be cause and effect, but it doesn't prove it. It's a necessary but not a sufficient condition. First, one should not expect similar sequences of growth rings from trees of a different species. Different species of trees would tend to have different growth rates in the sequence of the growth rings. Now, if we're looking at the thickness of the rings for the amount of rainfall and so forth, then we can see some correlation there. But different species could easily have different correlations because they may react to a drought or to more rainfall in different ways. Second, the growth rings are expected to be different for the same species that are growing in different areas, because if the tree rings are determined by the amount of rainfall and other weather patterns, then we would have different rainfall patterns in different locations. And that would give us different growth rings, or different patterns of rings. Third, young trees of the same species grow wider rings than older trees. As the tree ages, the rings get narrower, the outer rings get narrower than the inner rings. This makes correlation of the different rings more difficult. So it makes them more difficult because of that problem. Have another problem. Many trees grow more than one ring in 1 year. Now that some people don't realize that, but others do not grow rings some years. Some years they don't even grow a ring. And so we have a loss of rings. We have no rings there for a certain period of time. The growth rings of all trees should differ when they exist in different areas, one in North America, another in Ireland, another in Germany, for example. And they've correlated growth rings of trees in North America with those in Ireland and Germany. We'll see that. And these are quite some distance apart, and the weather patterns will be different during those time frames for those trees. So this is another problem we have. Now, here's a problem that they run into. How much correlation do we have to think it's significant? There can be correlation between things, and there'll be any significance between them. A low level of correspondence among the master chronologies prohibits the merging of 4 separate chronologies into one. Now, this is Krebs talking about 4 different strands or stands, areas of bristlecone pine trees, of certain pine trees. And so the merging of the 4 separate chronologies into one, it prohibits it from it. The validity of merging chronologies over extensive geographic areas for dendrochronologic purposes is questioned. So Krebs questions whether this is even valid. And the results of this study refute generalizations made in a previous study of the Mount Goliath bristlecone pine stand. Now, bristlecone pine are trees that live a long time, and they have one that the government doesn't tell anyone where it is because some crazy people would go out there and probably kill it, just to say I killed a 4,000-year-old tree. But we have people that are nutty like that, and so they don't tell us where it is, but they call it the Methuselah bristlecone pine tree. It's named after Methuselah. Developed master chronologies for 4 Colorado stands of bristlecone pine trees. And when he did, he could not correlate these 4 stands of bristlecone pine trees in the same state. This in the state of Colorado in the United States. So he couldn't correlate them. And so how in the world are you going to correlate bristlecone pines with trees in Germany and Ireland? This is ludicrous. If you can't correlate the same species of tree, bristlecone pine, in the same state in the United States, the whole system of correlating tree rings is brought into question. Let me give a little bit of background information to this before I go further in this. The chronologies were thought to be they began to use dendrochronology originally, not to give the age of things so much as to go back and look at the sunspot activity, to correlate sunspot activity. because the cycle of the sunspot activity, they thought that they could find the cycle of it in the chronologies, in the dendrochronology, in the tree rings, recorded in tree rings, and I think there was a correlation. And so there may be other factors giving us this correlation, and it may be such things as sunspot activity or other activities that we might have in the solar system, for example, such as sunspot activity and other things of like nature. So there's other factors that could cause the correlation. So we understand now, if you really understand statistics, and if you're really going to do scientific study, you have to understand statistics. And correlation does not guarantee cause and effect. It may be correlation from another reason or just strictly random situation that brought about correlation. Statistically, correlation can occur with there not being any relationship. Random information. If bristlecone pine trees cannot be correlated in the same state, then other species cannot be correlated. It doesn't make any sense that they could be. Bristlecone pines cannot be correlated in the same state of Colorado, the United States. Therefore, other species cannot be correlated with any certainty. Clearly, the technique of correlating tree rings is flawed here. We're going to see other flaws in it as we develop this. But they use the tree rings, dendrochronology. They use it to date and the overlapping of them to date certain things, and to use that to calibrate their radiocarbon dating. Different stands of bristlecone pine trees in the state of Colorado can be correlated. How can one expect to use the bristlecone pines to correlate the oak trees, a different species in Ireland and Germany, a great distance from Colorado? That doesn't make any sense. Remember, the correlation does not prove cause and effect anyhow. It really doesn't prove it. And so they're making arguments to supposedly prove something, and the argument logically doesn't prove it, because correlation does not establish cause and effect. If you have cause and effect, there has to be correlation, but it doesn't work the other way. In dating tree rings, the precision of the laboratory and that of Groningen and Heidelberg approaches the limit set by the faithfulness of the record in individual trees. This record can, however, produce ambiguous calendar dates from a single radiocarbon date. Hedges says we can get ambiguous calendar dates from a single radiocarbon date. So we could take a radiocarbon date and get ambiguous calendar dates from that. That's very interesting, because the radiocarbon, the amount of radiocarbon is not constant, and it hasn't been. And we're going to see some other factors as we develop this. We'll explain Hedges' point here, why this could happen, and we'll give other evidence for it. Here's another quote. The master tree ring chronologies of the last 2 millennia, that's the last 2,000 years, are absolutely correct. They form a perfect calendar and were produced using robust chronology building techniques. This is circular reasoning. They calibrate the radiocarbon dating system by the tree rings and then date the tree rings by the radiocarbon. And if you really read what they're saying there, that's exactly what they've said. And that's precisely what they're saying. From the last slide now, we come back to it. They say replicated. Let's go back to our slide. And we'll skip my points here. And I'll skip the second bullet here. The master tree ring chronologies of the last 2 millennia are absolutely correct. They form a perfect calendar and were produced using robust chronology building techniques. Replicated a high precision radiocarbon activity measurements made on precisely dated samples drawn from various chronologies make up the internationally accepted calibration curve for the conversion of radiocarbon dates to true dates with this time method. So we date the radiocarbon dates with the the dating of the tree rings with dendrochronology, and we turn around and verify with our radiocarbon, we verify the dendrochronology. And that's, of course, circular reasoning. Here's another one, another site. The dating by tree ring chronologies has brought about a crisis in the interpretation of ancient events by both historians and archaeologists. This is Neugrosch, 89 and 90, as I cited. He discusses this problem extensively, pages 37 to 41. This crisis is similar to what would occur if an accepted dating system dated the American Revolutionary War as occurring in 1861. It would be a crisis for the archaeologists, historians. And so we have a problem here. We'll see some of these crises. And here's part of the problem. There's a problem with the dating of the Minoan eruption, which may never be resolved. Direct radiocarbon dating has so far yielded a large scatter of dates that can at present be interpreted according to one's prejudice. So our radiocarbon dates here give us all a scatter of data, and you can interpret it according to your prejudice, what your preconceived idea is. Just pick your data, pick your results. Indirect methods, acidity peaks, tree rings, are beguiling, being potentially more precise, but at the same time highly ambiguous, and should only be treated with utmost caution. Powell tells us. Again, these are some of the people working in this area. This is what they say about it. So we need to be very careful when their own people, probably most of these are atheists. Large dating areas could occur when a long tree ring chronology is developed to a cross-dating of overlapping series that are relatively short. For example, two series, each 1,000 years long and representing the same time period, can conceivably be mismatched into such a way as to result in erroneous chronologies that are 2,000 years long. So he says they can actually overlap them. And now, as I pointed out, the tree rings do follow a pattern, and they go with the sunspot cycle. There is a weather pattern cycle that follows the sunspot cycle, and there's some other cycles, the cycles of the sun, that affect the pattern. And all of this, when you overlap them, you could overlap and pick up two series. And he admits here that you could take two series that were essentially together, overlap them, and wind up a 1,000-year period looks like it's 2,000 years. This is one of their people, one of their own people admitting this. Calendar dates assigned to annual rings of trees have traditionally been given in absolute terms with no explicit recognition of any uncertainty in the date. So we just state it right there, that's a fact. And we don't even recognize or acknowledge there's an uncertainty. The reasoning is that if cross-dating is carefully done, if a large number of tree ring specimens are studied, possible error is nil, and that's their argument. This may not strictly apply to the present case because of relatively small sample sizes involved and the unusually great lengths of the bristlecone pine chronologies. So right here, how many bristlecone pines trees have they been able to use and project backwards in it? And they don't have a large number of them. So, and you really get into statistics. When I was working on my doctorate degree for my dissertation, taking statistics classes and the research techniques, if you have a small sample size, and that's what they have here, admittedly, you have to have a strong correlation in order to draw any reasonable conclusions from it. And if you have a big sample size, your correlation can be weaker. You can have a smaller degree of correlation and still be significant. So it takes, with a small sample size, it takes a strong correlation for it to be significant, a significant result. But again, this is one of the things that many people do not understand. Correlation does not prove cause and effect. That's critical. That's a critical point. Now, how would we get correlation of tree rings and it not be dating from time? As I pointed out, sunspot activity, there's a correlation between sunspot activity and tree rings. And sunspot activity recurs on a regular cycle, like an 11 or 12 or something like that year cycle. And it correlates. There is correlation between it. The tree rings get wider and narrower during that sunspot cycle. There are also cycles of temperature cycles in the Earth, the temperature cycles, and we see that as well. But correlation does not prove cause and effect. That is really the person that uses correlation to prove cause and effect and draws the conclusion that he has a correlation there, therefore he has a cause and effect, is using bad reasoning. His statistical interpretation, his techniques are very really bad. They're just not good at all. Now here's a statistical technique. Linear product moment cross correlation coefficients are computed for 100-year subperiods, beginning with the subperiod centered on 4700 eon. That's 4700 years ago. The analysis was first carried out by using the dates originally assigned to the Campito chronology. The resulting coefficients are negative or have low positive values prior to the most recent subperiod. So they got negative coefficients. That usually says it's not a correlation. That's what that means, or very low positive values. When the Campito dates were adjusted, now listen to what they did. They got negative results, but they adjusted the Campito dates by insertion of 2 missing rings. So they inserted 2 missing rings. The cross-correlation coefficients for the entire period are positive and highly significant. Correlation analysis therefore verifies the adjustments made in Campito chronology. So we inserted 2 pieces of information that we didn't have. And when he got it inserted in here, all of a sudden this all works out. Did they work on finding something to insert? All you got to do is just with a computer, just put the data in, keep putting the data in, find what you need and insert it. And this is bad science, really bad science, to insert missing data. You always work with the data you have. It worked, therefore it was right. And we don't even know how honest they were in doing this. But they're not good scientists by inserting missing data. That's bad science. They claimed they were justified in their insertion of the missing data because the results are highly significant statistically. All I got to do is, if I got a computer, I can just fiddle around with it and find the data I need to insert into to get the good information to get my statistics to work out. And that's bad. It's not even honest. It shows that they're either not very well grounded in the techniques of statistical analysis or they're dishonest, one of the two. Well grounded, they have no business drawing conclusions. If they're dishonest, they're unworthy of being listened to. In some instances, the rings were only 2 or 3 cells in width. These rings were discarded and not used in the correlation analysis. They tell us that. So the rings are narrow, and so we just threw them away. We threw away data. So they threw away data that they had and treated them as if the rings didn't exist. And bristlecone pine, the boundary between, this is a quote now, late wood in one ring and early wood of the next is almost invariably sharp, with no evidence of gradation in cell size or wall thickness. The rare exceptions occur when extremely low average growth rates are produced sequence of rings of only 2 or 3 cells in width. So that's why we did this. So we threw this data away. So they threw data away, discarded information to make the statistics work. Again, If you did that on a doctoral dissertation, they'd give you the horse laugh and kick you out. You wouldn't get it. Pass dissertation wouldn't pass. However, he goes on and says, because growth rings are difficult to identify in such intervals, they're normally discarded for dating purposes. So we just throw them away. Throw away data and do not represent an important source of uncertainty in tree ring dates. So that's what they're saying. We throw away data. So we throw data out if it doesn't work. Pretty bad scientific approach. The statistical approaches, the research approaches are flawed. How many rings are discarded or discarded is not used in the statistical analysis. Practice commonplace in dendrochronology. Is this justified? And all of these raise serious questions about their integrity even. Case in which the trees supposedly grew at the same time for several hundred years, correlation was not known for the whole period in which the growth was contemporaneous, but it was broken up into short segments, a small sample size. Why was this done? Was it done because it didn't correlate? Remember, we've already seen there was a correlation positive for the whole period in which the tree grew simultaneously. Is this valid? Is this valid technique, statistical technique? When I studied statistics, and I'm not an expert, and I've had 18 semester hours of statistics, but most of it graduate level. But I don't claim to be an expert by any means. But I did learn enough that you don't throw away your data. You keep the data you got. You have to live with what you got. So, but they're throwing away data. They're just ignoring information. They discard information. They insert missing information. They employ a sample size that's so small it makes the correlation have to be quite large in order to have any meaning, any significance. This is a major problem for their system. With regard to the insertion of missing rings in the statistical process, this author, that's me, Marion Fox, agrees with Gladwin. Gladwin wrote, to include missing rings would merely correlate the opinion of the operator, not the evidence of actual tree growth. I believe he's just right as he can be. Page 7, Gladwin. The Berkeley Jews wrote, that atomic bomb tests of the late 1950s, early 1960s have yielded valuable geophysical information. The bomb test added substantial amounts of radiocarbon to the natural background, that is, carbon-14 to carbon-12, as approximately 10 to the minus 12. That's 1 millionth of a millionth. That's 1 pico amount. And so that's a pico. A millionth of a millionth, leading to maximum tropospheric concentrations around 1964. So they, 1964, we kind of maximized them out, and that's pretty well when they kind of quit having atomic bomb tests. So maximized out. So this created an error and provided a large amount of radiocarbon into organisms at that time. I suspect this may be part of why we're having increased cancer rates in our country and worldwide. This atomic bomb test probably gave it to us. But I'm not going to digress off onto that much further. Another possible source of error in the radiocarbon is the fossil fuels. This has not been talked about very much and has been totally ignored or maybe not even recognized, particularly coal and oil, which are burned, they produce non-radioactive isotopes. To a large extent, they don't have much radiocarbon in them. According to their dated age of them that the atheist gives, it shouldn't have any radiocarbon in them, but they do have some radiocarbon in them. That poses a problem for them. Also, we got a problem, is there radiocarbon in diamonds? Shouldn't be any at all. It should be devoid of radiocarbon. Shouldn't have any at all. But what we find is there's the fossil fuels, coal and natural gas and petroleum products in general. They don't have very much carbon-14 in them. They contain mostly 6 carbon-12 and 6 carbon-13, the two non-radioactive isotopes that are stable of carbon. 6 indicating the number of protons, and 12 and 13 indicating the number of total particles in the nucleus. That would be the sum of the protons and neutrons. 6 carbon-12 has 6 protons and 6 neutrons in its nucleus. 6 carbon-13 has 6 protons and 7 neutrons in its nucleus. Carbon-14 has 6 carbon-14 has 6 protons and 8 neutrons in its nucleus, and it's radioactive. It's unstable. It decays. So we don't have much carbon-14 in coal. So as they burn fossil fuels, they actually increase the amount of carbon-12 and carbon-13 and lower the ratio of carbon-14. So we don't produce much carbon-14. So what this amounts to is it makes the plants that are growing there look older. So this burning of coal or fossil fuels that began in the industrial age made certain plants look older than they were. And so that would make a radiocarbon, that would make it off a bit. So we have a problem with that. Ratio of radiocarbon and non-radiocarbon is used to date the sample. Remember that. That's how they date it. The decaying magnetic field of the Earth, as we've set forth, and even the atheist admits it's been decaying, allows a greater number of particles, neutrons and protons now. It mostly affects protons now. Most radiocarbon is produced by neutrons, and there are some, however, produced by protons. Protons will be affected by a magnetic field or deflected, and so their path will be deflected. And so what we find is neutrons would continue on through from the solar wind, and they'd create more radiocarbon if we have a weaker magnetic field. The protons particularly would. We have another problem we haven't set forth here, and I'm not going to go into it in very great detail. That is the upper atmosphere having large amounts of the theorized, postulated amounts of water vapor in it, the canopy, as I've set forth, that would shield and absorb some of the neutrons and protons both, and keep them from producing radiocarbon. So before the flood, when we had the water vapor canopy, we would not be producing very many, if a very few amount of radiocarbon atoms would be produced at that time. So again, that would make things look older because they wouldn't have as much radiocarbon in them. It makes artifacts appear older than they really are. Both of these factors do. Error is magnified because the erroneous assumption that radiocarbon has been at equilibrium for millions of years, in which they've admitted is not true. And that should be egg on their face to begin with. Volcanic gases have produced false radiocarbon dates over 100 years too old in modern plants from Thera. So volcanic gases coming out won't have any radiocarbon in them. When the plants absorb them, they don't have radiocarbon in the plants, in the stems of the plants. They're taking in almost entirely the two isotopes, carbon-12 and carbon-13. And that's what they're taking in. And so they look very old because they don't have any carbon-14 in them. Laskin cites a number of examples of anomalous ages. And anomalous is the word that doesn't go by the normal law. And it doesn't go by the laws that they think that they expect it to be younger than it is. And so here's ages of plants growing near volcanoes that are the source of carbon dioxide. So when they take a plant growing near a volcano, they find that if they date it with radiocarbon, it appears to be several thousand years old, and it's a plant that was growing, and they just cut it a few days before. So it's they have a problem with that. The gas that's coming out will make it look much older than it is. Here's another side of this. In Italy, Salp et al. Measured living plants, bush, trees, bushes, and reeds, and volcanic emanations have been sampled in their 14C, that will be carbon-14, radiocarbon content measured. All present-day plants are depleted in 14C of carbon-14, giving a fictitious age difference from zero, meaning they cut it down, and that's zero age. I mean, right then. And so they're giving a fictitious age difference of 1805, 1820, 25, 40, 43, 50 years BP before present. So the plant looks like it's 4,000 years old, and we just cut it down yesterday. So kind of interesting. So that's a significant error in the dating of it, because this is right near a volcano. So if it had a large amount of non-radioactive carbon, carbon-12 and carbon-13 in it, and almost no carbon-14 in it, the plant would look much, much older than it actually is. And so my flood model would provide a situation where we'd have less radiocarbon in the atmosphere before the flood, almost none before the flood. And it would build up after the flood. An overestimation of age is measured by 14C carbon-14 methods can occur in plants grown in a volcanic environment. This is salt, even at the sulfuric stage, because part of the atmospheric CO2 is of volcanic origin and contains no 14C or carbon-14. The dilution of atmospheric carbon dioxide by volcanic CO2 can be considered as a natural carbon-14 dilution. It was previously noted from Hawaii. So again, this dilutes carbon-14, makes it look older than it really is. So our atmosphere should have more carbon-14 than we have, and we have it being diluted, and it looks older than it really is. It makes it even worse. So the whole situation is really a problem for the atheist and the old age creationist. Investigations on the possible influence of volcanic CO2 carbon dioxide on plant material have been reported before. They show that active volcanism, as well as volcanic gases emanations, may lead to considerable pseudo-ages, pseudo is false ages, in archaeologic or recent material. And again, this is very, very revealing to us. The influence of dead carbon dioxide on the plant materials. By dead, I assume he means it has no carbon-14 in it. Causes pseudo-ages up to 1,500 years, exceeding the usual uncertainty of global 14C carbon-14 variations. Bruns tells us 1,500 years, that's off by 1,500 years, the dating of it. That's pretty significant. Remember, you can't go back more than about 40 or 50,000 years with radiocarbon dating with all their assumptions. Anyhow, so if they got an error of 1,500 years in the dating, that's pretty significant. They get the expected age, it was good. If they get the expected age, what they expected it to be, then they consider it to be a good sample. If they don't get the expected age, then they say, well, it was contaminated. That's a convenient way to reason. Very convenient, and they get what they want with that kind of reasoning. In areas of recent volcanism, the plants capture volcanic carbon dioxide devoid of carbon-14, as well as atmospheric CO2. As a result, there's a decrease in radiocarbon concentration in recent wood. And that's exactly what we're saying. The apparent radiocarbon age of such recent wood comes sometimes to 6,000 years. It appears to be 6,000 years old, and it's recent wood. Pretty significant error. It's highly significant. And we noted also the tilt of the Earth on its axis. it would get more or less production during different seasons of the year. Tendency toward an older radiocarbon age as a result of capture of volcanic carbon dioxide by plants can take place over large areas and regions of young volcanism. So this can happen in large areas. This leads one to the conclusion that widespread volcanic activity, which probably occurred immediately after the flood, would upset any radiocarbon dating of the organisms that lived at that time frame significantly. Brown and Hughes say the 14C carbon-14 anomaly that is said to have occurred in 1909. So there was an anomaly that occurred worldwide, pretty much over a good portion of the world in 1909. The carbon-14 activity was higher in that year than normal and deviated from the mean. Mean is the average over 2 standard deviations. That's significant. 2 standard deviations is statistically highly significant. So we have an increase, significant increase in the amount of carbon-14 in 1909. Well, it was the Tunguska Valley impact in Siberia. Something hit there. They don't know what it was. There are some various theories that's what it was. The sound of this impact was heard in London, England. And we'll show a map here. That's now, Brown and Hughes say, we conclude, therefore, that within the uncertainties of the effective chemical composition of collected plasma acceleration processes and on collisional neutron production, the number of neutrons expected in the Tunguska impact or scale from solar flares is in remarkably good agreement with the radiocarbon data requirements. So they assume that this Tunguska impact produced this extra radiocarbon. The mathematics of it figures out from the physics of what should have happened. The neutrons being produced would have produced this. On June the 30th, 1909, a region of Siberia, Tunguska, experienced an event that caused devastation. Barographs, that's air pressure, and that was what we would call a barometer now. Air pressure measurement devices detected a change in the barometric pressure in Great Britain, and this is quite some distance away. Seismic instruments recorded the event around the world, estimated at a 5.0 on the Richter scale. Now, the Richter scale is a logarithmic scale, and so when you go up by one on the Richter scale, you double it. So it's an increase, it's a logarithmic increase, but we won't get into that, but a 6 is a whole lot more powerful than a 5. Yeah. Phenomenon known as bright lights, was observed in Great Britain and other places throughout the world on that date. The Mount Wilson Observatory observed a decrease in the transparency of the atmosphere for several months after the Tunguska event. So there was a decrease in the transparency of the atmosphere. So something happened to loft something up into the atmosphere. And it took several months for it to settle out. Shock waves and explosions were felt and heard hundreds of miles away. Now here's the impact site right here, Tunguska event. And right over here is London is way over here off the map. But they actually heard the explosion in London, England, not far away. When I went to Russia and lectured, I was right in this region right here, pretty close to the Arctic Circle in here, right in this region. This is where I lectured in 93, 94, right in here on the Volga River. Yaroslavo is the name of the place. But this is where Tunguska occurred, and they heard it clear in London, England. This is an artist's sketch of it, what happened. And this is a picture taken in 1928. I remember this occurred about 9 years before this, but they took a picture of this. This is trees laid down It's like there had been some explosion and laid them down and all pointing in the same direction. Right here is some more of those trees, pictures of those trees. Communist country at this time, remember that, okay? Here's more pictures of this, of the trees. And here's another one, an aerial picture of Tunguska. Of course, aerial photography back then wasn't near as good as it is now. And they think they found where the crater occurred. And they think they may have found it. Here's where they think it occurred. Here's the epicenter of it. And of course, sediment could come back in and fill it back up. So that's what they think happened. Here's the, this is kilometers now. A kilometer is 0.6 of a mile, roughly. So right here, this is 25 kilometers across here. That's probably about 25 or 30 kilometers from here to here. So this is the way the trees are laid, like, and they're pushed out in all directions like you would have from an explosion. And of course, an impact would create an explosion. Here's the aerial extent of which the bolide was sighted. They could see it. And so they could see it in these various places in the former Soviet Union and in Russia. Now, since radiocarbon is also generated by solar protons, what we found is, let me lay this out, back up a minute. This impact, whatever this was, and they think it may have been a comet. Some even theorize it might have been a bunch of antimatter. And there are other theories about what it might have been, but probably was a comet. But anyhow, whatever it was, it created a large amount of radiocarbon. Significant amount, increased two standard deviation above normal. But radiocarbon is also generated by solar protons, the Lingenfelter and Flom, pages 134 to 140. It's also possible that bolide impacts. Now, bolide, of course, is an object coming from space, such as a meteorite, could generate enough energy to create radiocarbon by protons. If it hit hydrogen atoms, it could in fact, cause them to lose their electrons and become protons and cause them to create radiocarbon as a result. Bolide impacts during the flood probably created radiocarbon by neutrons and or protons both, just like Tunguska occurred. And I believe there were extensive bolide impacts during the flood. And our evidence has already shown that to be the case. Now, if this happened, then we would have a lot of radiocarbon produced during the flood and make the things look younger, look older than they actually. Because the radiocarbon produced, there would be no radiocarbon, almost none, before the flood. So this would give us, making the atmosphere look older than it really is. The atmosphere look older. The present communication, we discuss Libby and Lucan say, carbon-14 production in thunderstorms and show that its present day magnitude may be a few percent of the carbon-14 production by cosmic rays. So a few percent. So the 100-year fluctuation frequency of thunderstorms could explain the short-term secular variation of radiocarbon in tree rings. So again, now we see this 100-year fluctuation in the frequency of thunderstorms, which they've noted. And this has nothing to do with people burning fossil fuels, okay? This is 100-year fluctuations in the frequency of thunderstorms. Now, thunderstorms produce lightning bolts that create radiocarbon. And so we see a short-term variation in this secular variation in the radiocarbon in tree rings. So if you're using the radiocarbon in the tree rings to date the trees, and then turn around using the tree rings to date the radiocarbon, which is circular reasoning, of course, now what they've done, they have another problem. Is this, and the correlation of the tree rings might follow the 100-year fluctuations in the frequency of thunderstorms. Might be following that. It might be following the cycle of the sunspot activity as well. The cycle that we have there, I think it's about 11-year cycle there. Variation in cosmic rays, both solar and galactic, can affect the rate of 6-carbon-14 production. These rates could be normal variation in which sources are supernovas, or from such sources as supernovas. These variations, so a supernova is a floating star, of course. These variations linked from Earth's decreasing magnetic field could greatly affect the production of radiocarbon 6-carbon-14F. First, here's a summary of problems with radiocarbon dating. The decay rate is not known with any degree of certainty. Second, there are good reasons to believe that the antediluvian environment prevented the production of radiocarbon. We have other things producing it than we have if we just use neutrons to produce it. Protons, bolides, lightning produce it, other factors. And we have the problem with we have reason to believe that the antediluvian atmosphere didn't have any. And that would make things look older than it existed prior to the flood. It looked very, very old. And there probably was production of radiocarbon during the flood. So again, the whole system is flawed. And of course, they want to ridicule and make fun of the idea that there was a flood. But my model then explains why their dating system has flaws in it. So this concludes our summary of our problem. Third, radiocarbon comes from several different sources: the solar wind, cosmic rays, lightning, meteorite impact. Fourth, volcanoes injected large amounts of non-radioactive carbon, 6-carbon-12 and 6-carbon-13 into the atmosphere for several centuries after the flood. Other problems: the radiocarbon tends to be diluted by limestones and other rocks. Second, of other problems, some organisms tend to reject one isotope of this of an element in favor of another isotope. This is called fractionation. Third, the carbon in the fossil tends to be contaminated by water that leaches out of the carbon in the fossil. So it can be contaminated. Fourth, water tends to transport some carbon into the fossil. Fifth, various reservoirs have discordant amounts of radiocarbon. We've already shown this. Carbon dating requires extrapolation of the data, mathematical extrapolation. Students of mathematics should remember that it's dangerous to extrapolate data when the variables are unknown. Very dangerous. So that concludes our summation of most of the problems. We'll get back and do a little bit more with radiocarbon, but by and large, we finished our study of radiocarbon and with all of its problems.